here we are doing 5.9. So we have, they want me to just look at these equations and decide if they have one solution or no solutions. So let me tell you where my head is at with these. Where my head is with these is that if I have an isolated radical, I can tell. Because my isolated radical, if it equals a 0 or positive number, then that means that there is one solution. If my isolated radical equals a negative number, then there is no solution. And if you're wondering what I'm talking about with isolated radical, this problem right here is going to explain it all. It's going to make perfect sense after this. Look, the first one, this guy. This one is an isolated radical, meaning the whole left side of the equation is under a radical. Nothing outside the radical there. And that equals a positive number. This is a one solution situation, okay? Let's look at this guy right here. This guy, the whole left side is in the radical. This is an isolated radical, okay? And that one equals a negative number. That means there are no solutions here, okay? Let's keep going. Ooh, a very not isolated radical. Hold on. Let's go. Let's bring it down a notch first. Let's look at this one. Look at this. Radical, not radical, same side. This is not an isolated radical. That means we cannot judge this situation the way that it looks right now. So what we will do is you guys in math, you always have the power to change things, all right? We don't have an isolated radical. We want an isolated radical. Subtract the 3 from both sides. Get yourself an isolated radical. The square root of 4x will equal 1 minus 3, which is negative 2. Now we have isolated radical equals negative. No solution. This one. Isolated radical equals another isolated radical. Okay, this was none of the situations I talked about up there. But this is one where all I got to do is square both sides. And all the radicals disappear. Gone. And I end up with kind of a simple setup. Can 4x plus 3 equal 4x? Some of you might see this as, can something plus 3 equal that same something? And you might be able to see right here that no, it cannot. As soon as I add 3 to 4x, it's going to change. So it cannot end up equaling what 4x was from the start. However, algebraically, you can also see that there are like terms on the two sides. So you could subtract 4x to get those like terms together. And then here it cancels and we just get 3. That's not legible. We get 3 equals. And then on this side, 4x minus 4x cancels and leaves us with 0. 3 equals 0 is the algebra's way of telling you there is no solution. Okay, when there's a false statement, that's a no solution situation. Okay. Okay. Now let's go on to this bad boy. All right, here we go. This is a non-isolated radical. We want to isolate this radical. We got two choices, okay? Typically, we would think of moving the 3 over. I just want you to picture, if you move the 3 over, you still have this negative here. So then the next step would be to divide by -1, which is perfectly fine. 2 steps, boom, done. However, because this side of the equation is 0, I notice that if I just add square root of 4x to both sides, I'll have the square root of 4x on this side as an isolated radical, okay? So I just did it that way because I'm lazy, okay? If you want to subtract the 3, go for it, but then you have to divide the negative. So then you'll end up with a -3 when you subtract the 3, but then when you divide the negative, you still end up with the +3, the exact same thing we got. At the end of the day, this is a isolated radical equaling a positive number, so this guy has one solution. And then this one, kind of same as the other one where we have radical and radical. They're both isolated, meaning if I square both sides, they both go away. And then I have 4x plus 3 equals 3x. Okay, this one is different, okay? In this situation, I can subtract the 4x to get that 3 equals a -x. This is a solvable situation, x equals -3. You don't have to solve it. You just have to notice that you can solve it. So there's one solution, okay? Different than this one, because this one is 4x and 4x, and they weren't going to equal. Yeah, okay. Okay, here we are. Now we're actually finding solutions, okay? I'll tell you guys, when I had a test, I like to first look at all of them and immediately find the ones that had no solution, both because it was like a question done and out of like my plate immediately, which was nice, but also because I knew that once I was in the hustle and bustle and used to squaring both sides of an equation, I might encounter a question like number 3 and just square both sides and go without ever noticing that this is an isolated radical equaling a negative number, so it has no solution. So just saying, in a situation like this, I like to go, okay, I'm going to solve that one. Ooh, this one's no solution. Cubed, this one has a solution. And then this one I got to do, okay? All right. Let's do number 2. Number 2, step 1, you guys. We have the radical and the 4. If you want to solve this algebraically, you'll start by squaring both sides. And please note, anytime we square both sides, you've got to check your answers. Okay, cross it out. We get 2x plus 2 equals 16. And now you can solve this out. Subtract the 2, divide the 2. If you chose the algebraic method, I trust that you can do this. X equals 7. A quick check back. 2 times 7 is 14. 14 plus 2 is 16. Square root of 16 is 4. And 4 does equal 4. So this is good. If I did that too fast, just you try it. 2 times, plug 7 in for x, and simplify and see if the left side and the right side match. I wanted you to know that you can also solve this one with the table. Okay, if you start with x and build the function out, and then when you're working it back, put 4 right here and work it back, all right? I'm not going to do this one with the table, but I will do the next one with the table, okay? This is a cubic function, so I do not need to check, okay? I don't have to worry about extraneous solutions in this one. To solve this with the table, I first build my function out, all right? I'll start with x in the first box, and the first thing is plus 4. And then the next thing is cube root. And then we are done. So now in this box, I'll start with the opposite side, so -2, and let's go. Opposite of cube root is cube, so -2 cubed is -8. And then the opposite of plus 4 is -4, so -8 minus 4 is -12. And that means that x equals, -12. Okay? All right. X equals -12. This one, you guys, because our strategy is we are not really trying to isolate x here. okay? Because we've got x over here and x over here, and as of right now, that's not what's happening. So I would not use the table here. I would just go algebraically and square both sides. So I would end up with 5x plus 6 equals x squared. And now I can see that definitely I am not isolating x. You guys, anytime you have x squared and x present, you are not isolating x. You are moving everything to one side. Everything's on one side, and the other side equals 0. And then you're factoring. And this is the factoring that I told you guys. If you know no other form of factoring other than this type of factoring, you're going to be okay like 90% of the time. So please learn this kind of factoring. I do have a video on it if you need, okay? All right, here we go. Moving everything to one side. The goal is to keep x squared positive. So it's positive right now. I'm not going to touch it. I'll move the 5x over. I'll also move the 6 over. Okay, I don't want to move the x squared because I don't want to turn it from positive to negative. Cancel, cancel. 0 equals x squared minus 5x minus 6. You guys were a little rusty, I saw in class, all right? X squared and minus 5x cannot be combined. They are not like terms. Leave them alone, okay? All right, now let's go factor. What we are looking for are two numbers that can multiply to make this last number right here, negative 6, but add to make this number in the middle right here, negative 5, okay? And the reason that it's this simple is because x squared doesn't have a coefficient, or it does, but it's 1. Now, what numbers can multiply to make 6, but add or subtract to make 5? That could be 1 and 6. It could be 2 and 3, all right? So just pick one, see if it works. So I'll start with 1 and 6. Now here's the deal. Since the 5 down here is a negative, the 6 must be negative. And then negative 6 times 1 is negative 6. And negative 6 plus 1 is negative 5. So this is it, these two numbers. These two numbers are just going to go into your parentheses with x. So positive 1 and a negative 6. It's that simple in this particular type of factoring. And then now you have two x values, negative 1 and positive 6. These are the solutions, the opposite of the numbers you see here. And if you recall, we squared both sides up here, which means 1, 2, none of these guys might be extraneous, but we have no idea until we check. So I'll do the check a little bit more detailed here because this one's trickier. So let's start with negative 1. If x equals negative 1, plug it in. We get 5 times negative 1 plus 6 equals negative 1. And 5 times negative 1 is negative 5, plus 6 is 1, and negative 5 plus 6 is 1, and the square root of 1 is 1, and it is not negative 1. So this guy's out. And I know most of the time the negative 1's out, but don't rely on that. Make sure you check. Sometimes they surprise you. Let's see if 6 works. 5 times 6 plus 6 square root equals 6. And this is the square root of 36 equals 6. 6 equals 6. Yes, it does. So x does equal 6. Okay. Fill in the blank with an integer to create an equation with an extraneous solution. Très intéressant. Let's see. I'm thinking like a negative number. Actually, I'm thinking of not messing with this at all. I I don't want to square that. Yeah, I'm going to put a 0 and hope it works out, because anything other than a 0, you guys, like for example, let's say I put 1. Then when I square both sides, I have to square that, which means I have to FOIL that or distribute it or use the box and get x squared plus 2x plus 1. You see how complicated it gets? I don't want to do it. I'm going to hope a 0 is good enough. And if I square both sides now, I just have 2x plus 20 equals x squared. And then move everybody to one side. So 0 equals x squared minus 2x minus 20. So all I did was speed through what I did over here for you guys. Okay, so if you're stuck, go back and check how that happened. Okay, now it's not looking good that there are two numbers that multiply to make negative 20 but add to make negative 2. Because it's only 4 and 5. They only make 1, not 2. It's no good. Doesn't mean there aren't solutions. They're just hideous. It looks like my laziness has given us trouble, huh? I'm debating what to do here. If x was... Okay, so see how that's 20? I'm thinking the next pretty perfect square after 20 is 25, but that's an odd number. So I'm thinking it's 36, which means if 2x is 16, so if x is 8, this doesn't come out so bad. If x is 8, then this becomes 16 plus 20, 36, and the square root of 36 is 6. And then over here, if x is 8, and the extraneous solutions usually happen when one side comes out to be like negative. See here, it was 1 and negative 1. So I'm kind of thinking, because I'm lazy, to put a negative 10 here. No, not a negative 10. What am I saying? I think I got it, you guys. Check it out. If I put a negative... I want a negative 6, and x is 8, so I want a negative 14. Okay, let's check this out. This is what I'm thinking. This is how I came up with this. And then we'll, as I talk it through with you, I'll see if it actually works. I'm thinking if I put a negative 14 here, which that is an integer, so I have respected their rule, and x is 8, if I solve this, I'll get x equals 8 as a solution. So an 8 would go in here, and 2 times 8 would be 16, and 16 plus 20 would be 36. And then on this side, it would be 8. 8 minus 14 would be negative 6. And then over here, I would get 6 equals negative 6. And that would be an extraneous solution. Because it would work when both sides were squared, but it wouldn't work as it is. You guys, I do feel a little bit like I cheated. I didn't do it right. I didn't do it the way they probably intended. But I just don't want to do all that algebra. So let's move on. Let's pretend we're all good now. Here's a much more... Okay, unless I'm missing something and this question is like hecka easier than I'm making it out to be. Because number 7 is hecka easier. Look at this. You have a square root plus something equals 3. If you make this plus something bigger than 3, like anything bigger than 3, go with 4. Okay, then when you isolate the radical, you'll subtract 4 from both sides. and you'll get an isolated radical equals a negative number. Any number bigger than 3 here, and you are set. Put 5, put 100, put a billion, okay? This is a reasonable question. What the heck was this about? If you figure out an easier way to do this, like I made this way too complicated, please come and tell me. Okay. What is the solution to this? Check out this beautiful isolated radical equal to another beautiful isolated radical. All I got to do is cube both sides, wipe out these radicals, and get myself a really chill equation to solve. 3x minus 5 equals 8x minus 10. That means subtract the 3x to combine those two to get negative 5 equals 8x minus 3x is 5x minus 10. Then add the 10. Luca, are you okay? Yeah. Okay. Add the 10 and add the 10, and you get 5 equals 5x. So x equals 1. This one. Fill in the blank with an integer so that when solved, the value of x is as close to 10 as possible. When solved, the value of x is as close to 10 as possible. Okay, I like it. I don't quite know what this is about, but they want x to be as close to 10 as possible. So I'm gonna plug in like a 9 for x. And the reason that I'm going to do that is because the square root of 10 isn't going to yield an integer here. They want an integer. They want it to equal an integer. The closest number to 10 that will give me an integer is 9, because the square root of 9 is 3. All right? The next one up is 16. That's not close. Okay? All right. So now if x is 9, then this is 3 plus 3. Oh, shoot, it doesn't work. 3 plus 3 is 6, so square root of 6 is not good. Oh, I love it. Let's keep going. Let's keep trying. Okay, so if it was 1, 3 plus 1 would be 4. Square root of 4 would be 2. Okay. 1 is good. Because if x is 1, then this guy right here becomes the square root of x would be 1. And then 3 plus that would be 4. And then the square root of that would be 2. And then 2 plus that would be 4. And then the square root of all that would be 2. So if x is 1, we get an integer out, 2. But that's not very close to 10. So let's keep going. 2 is not going to work. 3 is not going to work. 4, if x is 4, the square root of 4 is 2. And then 3 plus that is 5, and the square root of 5 is not an integer. It ends right there. Let's go to the next square root after 4. That would be 9, which I already tried in the beginning when I got super arrogant and thought that I had already figured it out, and it didn't work out. And then now we're going to go to 16, because that's the next perfect square root. Square root of 16 is 4. 4 plus 3 is 7, and then that stops being an integer right there, because square root of 7 sucks. And then the next perfect square after 16, I'm not really going to bother you guys. It's 25. However, 25 is already further away from being 10 than 1 was. 1 is the only one. 1's the only one that is like as close to 10 as possible. So, yeah. Interesting. Yeah, I buy it. I think that's good. Okay, now they want me to come up with something where there will be two solutions. So I'm thinking, let's see this through real quick. If we square both sides, then I get 2x equals x plus something squared. And then the x plus something squared will be a trinomial. And then I'll subtract 2x from it. And then I think what I want is positive solutions. So I just want things to come out positive. So I want whatever number I pick here to remain positive after I subtract 2x from it. So how about 2? I think 2 will work. Let's try it. So if you can't really like plan ahead like that, just start with a number, you guys. And once you see how it went with that number, you'll be good. Okay, x plus 2 squared is x squared plus 4x plus 4. And if I subtract 2x from both sides, I get x squared plus 2x plus 4. And that doesn't exactly factor, but that doesn't mean there aren't two solutions. But there aren't actually in this case. So we need to go bigger than 2. We need to go like 3 or 4. 4 would give me 16, and 8 minus 2 is 6. I think 4 is good. If I did 4, the way this would change is that in the middle I'd have 8x, and at the end I'd have 16. And then when I subtracted the 2x from both sides, I would have a 6x in the middle. And then now, no, I think I'm not on the right track. Because maybe I actually... I can't think of two numbers and multiply and add. And if it was a 3, this would be a 9. And then this would be a 6, be 2. They didn't say the solutions have to be integers. I have a better idea, I think. I don't know. You guys, I really honestly don't know. This is a good one. These are good questions, but should we solve it with an A? Hold on, I think I just saw, oh my gosh, so much easier. I think if x is 0, there's two solutions, 0 and 2. Watch, because if x is 0, then you put a 0 here and 0 equals 0. Or you put a 2 here, 2 times 2 is 4, square root of 4 is back to 2 and 2 equals... So 0 is the easiest way to go. Which if you did what I said initially, which was just pick a number and get started, and usually start simple, you may have just gotten this right off the bat. Solving this out, you square both sides, you get 2x equals x squared. And if you do what I said, which is to move everything to one side and factor, the factoring's simple, just take out the common factor. So you get x equals 0 and x equals 2. Two solutions, they both work. I overcomplicated it. Okay, let's move on. And let's look at some exponent rules, you guys. When we're multiplying stuff with exponents, what do we do with the exponents? We add them. So we want to know what number plus itself 4 times equals 12. So that's 3. 3 plus 3 plus 3 plus 3 is 12. Okay? And then over here we have a power to a power. When that happens, we multiply. So the question is, what number times 6 equals 2. Divide by 6, divide by 6. N equals 1/3. Okay? Oh man.